This is a recording of the review guide for Unit I on solutions. So the questions in this review guide are similar to questions you might see on the Unit I test. And I promised someone I would put some jokes in here, so what do you call a fish without an eye? A fish. All right, on that note, here we go. This question asks for the molarity of a solution. Molarity measures concentration. So if you put an amount in a volume of solution, you should be able to use the formula M equals N over V. This is kind of important. The difference between milliliters of solution and amount of water are not the same. Those two things are different questions. When we make a solution, we usually have a volumetric flask that goes to like an exact number, like 100.0. So that's just a small distinction. So moving on, if you have this formula, M equals N over V, the question tells you only the V. That's the only variable it tells you, for sure. It tells you grams of calcium chloride, and then from grams of calcium chloride, you can determine the number of moles. So after you determine the number of moles, you could write it in the N space, 0.0433 moles. Now you have enough variables that you can use the M equals N over V to determine the concentration. Okay, so if you put this in your calculator, the number would give you 0.21019. You have only 3 significant figures for both of the values in the problem, so your answer should be 0.210 molarity. The second question is virtually the same type of problem. It gives you an amount of solute and a volume of solution. This was a typo, so that's a mistake if you didn't hear it in class. It gives you a volume of solution, so it's, again, the same formula, M equals N over V. So after you solve for the number of moles, then you can use N divided by V to produce a final concentration. So the number from the calculator is 0.4150, and since this question only has 2 significant figures, your final answer should only have 2 significant figures, so you have to round 0.4150 to 0.42. Question 3 is a little bit different. It gives you a concentration and a volume and asks for how many grams. So if you have a concentration and a volume, you can rearrange this formula to solve for N. N is the number of moles. And so if you calculate these two, you get 0.8 moles. But that's not the question. The question is how many grams. So it's not difficult to change moles to grams. You use the molar mass from the periodic table. So 0.8 moles times the molar mass of sodium chloride gives you this number on the calculator. But since both measured values have only 2 significant figures, you round 46.7 rounds up to 47. Okay, question 4 is one of the most commonly mistaken questions for students. They have a difficult time understanding what is V1. And V1 is the amount that's transferred. So the question is, how much stock solution? That's V1, the amount that moves out of the original and into your final concentration. That's the V1 value. So this question is changing a very concentrated stock solution to a less concentrated sample solution. So you are literally diluting it. So you have to add some water. So the amount that you take out is V1, and then how much water you add depends on the total volume of the solution. So the first step is to determine how much of the original stock should you pull out, and that uses the formula M1V1 is equal to M2V2 because you are diluting it. All right, you can rearrange the values to determine that you need to move 116 milliliters. So if you have to take 116 milliliters out of the stock and put it into the sample, and you need a total of 355 milliliters, the next question is how much water? So from here, you take 116 plus what number is equal to the total, 355. So that's just a subtraction problem. 355 minus 116 is equal to 239 milliliters of water. This is the same type of procedure that you should have conducted in the rainbow dilution lab. Okay, question 5 is very similar again. It uses dilution, so you are changing something from a stock solution that is 2 molar to a less concentrated sample solution that's 0.75 molar. Okay, so again, the amount you move is V1. So, since you're diluting it, you use the dilution equation, rearrange, solve for the amount of chemical. So since you're using sodium bromide, you need 0.11 liters of the original. And since you're trying to make 300 milliliters, if you wanted to do the math, 300 is the total, is supposed to equal 110 plus how much water? So 300 minus 110 is equal to volume of water is going to be 190. Okay, question 6 goes back to using the concentration formula. If you want a molarity and you have this amount, you can use M equals N over V. However, neither moles nor volume are provided in the question, but you can calculate the number of moles. So since you're given a mass of Ki, you need the molar mass from the periodic table, change grams into moles by using dimensional analysis. After you have solved for N and you know the molarity, this formula has to be rearranged. Now, this is actually a pretty common mistake from students. To get V by itself, you have to multiply both sides by V. That means M times V is equal to N. And then to get V by itself, you have to divide both sides by M. So that means that V is equal to N over molarity. Oops, molarity, capital M. So that's the rearrangement that you need to do correctly, so your algebra is important here. After you rearrange to put moles on top and molarity on the bottom, if you solve for this number, you end up with 320 milliliters. You may have, when you do it on the calculator, you'll get 0.32 liters. Those two things are equivalent, so either answer is fine. Okay, I'm not going to explain each of the vocabulary terms, but I'll go through them to show you my answers. You can pause the video if you'd like. Here's the second page. Oh, the second half of the first page of definitions. And here's the final definitions from the review guide. That's all I have. Good luck on your test. Let me know if you have any questions.